Okay, thank you. All right, so we're going to go to current lessons and go to the notes that are on there. And we're going to, it's right here. Remember, you're going to watch this video on your own. And here is the notes. We're going to go ahead and open those. I'm going to move this out of the way so I can see. Okay, so here is a periodic table. So yesterday we talked about the little boxes. So if you look at the little box here, it's going to look similar to what you practiced yesterday. So it has the atomic number, it has the symbol, it has the element name, and it has the mass. Now, looking at the entire periodic table is what we're going to do now. When we look at the periodic table, the elements are listed in columns, and those columns are called groups and families. The reason why they're called groups and families is because they're somewhat related. And even as you cross the periodic table, the way they're related is still similar, like stepping stones. They're a little bit alike as you keep moving over. Now, the ones over here on the left are going to be the ones that are highly reactive because they have very little valence electrons. Valence electrons are the ones that are on the outside of the atom that are the ones involved in chemical reactions. So when we go across the table, elements become more and more stable. These elements on the very far right are the ones that are already stable. So you have helium balloons. They don't blow up on you. Neon, argon, krypton, and xenon, those are all types of lights. So when they light them up, when they ignite them, they turn colors. They're not explosive because they're stable. That's why we can use them as those cool looking lights. When you look back on the left, if you look in the middle of that on 19, it's potassium. Potassium's in bananas, but bananas don't explode because that potassium is bound to something else. It's bonded with something else. But if you use potassium as it is on the periodic table, which is how it exists in nature, it does not explode. It does explode. It's actually highly explosive. So it wants to bond. All these elements on the periodic table want to bond, and they all want to look like the ones over here on the far right. They want to become stable and neutral. So what happens is bonding occurs, and the types of bonding we mentioned, which was covalent, ionic, and hydrogen. Now there are other bonding types. We're just only talking about those three at the moment. These over here are metals, except for this guy up here. He's a non-metal, but because he's similar to these guys in characteristics, he lives in this family. Technically, he has his own family, the hydrogen group, but he lives over here because he's similar to these guys. Now, all of these right here are metals, so are these, but when we talk about valence electrons, we're actually going to exclude this group down here. This row down here, these two rows down here, actually fit right here in this spot, and they're moved down because we don't want the periodic table to be humongous. So if you want to see what that looks like, it's called an extended periodic table. Now, as we move across the table, what we're trying to look at is how many valence electrons does every element have? It's super easy. If you look right up here at the top, you're going to see that we have numbers. That 1 through 18 is telling us how many columns, groups, and families we have. However, these groups 3 through 12 are actually the same family. They're called transition metals. Now, if you look at the bottom, the 1A across the periodic table, you'll see that it goes from 1A to 2A. We skip over the B's. We go back to 3A, 4A, 5A, 6A, 7A, 8A. Those are all the valence electrons, if you can't remember. Some periodic tables don't have it up there, but this one particularly does. So for example, hydrogen has 1 valence electron. Oxygen has 6 valence electrons. Carbon has 4. See the 4A up there? That tells us how many valence electrons. Now, I want to show you when we have these over here are metals. Metals are going to bond with non-metals to make covalent, ionic bonds. The metals are going to give up an electron, and the non-metals are going to take the electron. And because an electron is negative, when a metal gives away that negative charge, it becomes more positive. When the Non-metal takes the negative charge, it becomes more negative. So this is more positive, this is more negative, and because of the positive negative, they're attracted to one another. Because of that attraction, that's why they form an ionic bond. A covalent bond is only between nonmetals. So again, an ionic bond is between a metal and a nonmetal. A covalent bond is between two nonmetals, and a hydrogen bond is a covalent bond, nonmetals, with hydrogen in it. Hydrogen is a nonmetal. It's over here only because of its characteristics. So let's look at how to look at the valence electrons. We mentioned how we find the valence electrons on the periodic table, but let's look at it again. So if I have nitrogen, I don't want to use nitrogen because we talk about that here in a second. Let's do carbon. If I have carbon, carbon has, let's go back to our picture of the periodic table so you can see what I'm saying. If I look at the periodic table, carbon is here. Carbon has 6 electrons. So let's go back and write 6 electrons on our picture because that's going to show us something. We have 6 electrons for carbon. Now, when you have an element and you want to show all the electrons, it's called the electron configuration. So if I want to show all the electrons in carbon, the first energy level is going to hold 2 electrons. Then the next energy level in this case is going to hold the rest. So 6 minus 2 is 4. So I'm going to put 4 electrons on this second energy level. Now, I just told you earlier that all the electrons on the outside are going to be the ones that are involved in chemical reactions. So in this case, carbon has 4 electrons that are involved in chemical reactions. Those 4 electrons, if we go back to our picture that we had of the periodic table, are going to show up here at the top. If you look above carbon, you're going to see that 4A, that's telling us how many valence electrons. And if you remember us saying that in the picture we saw that it has 4, that's how many valence electrons. This electron configuration where we write all the electrons isn't necessary for what we want to know. So we don't have to draw this big picture with all these electrons. The only electrons we want to worry about are the ones on the outside. So let's look at water, for example. If we want to know how this molecule or compound share electrons because they're 2 nonmetals, and because they're 2 nonmetals, they're going to create a covalent bond. They're also going to create a hydrogen bond because hydrogen's in it. Right? So if I look at hydrogen alone, it has 1 valence electron. It also has 1 electron in general. Hydrogen, in order for hydrogen to become stable, it's going to want to have 2 because that first energy level can hold 2 electrons. Oxygen has 6 valence electrons. And hydrogen again has 1. This is not 1 over here, that's an H. Okay, so what we call these dots I put there are called the Lewis structure. And if I were looking at neon, the Lewis structure would have 8 dots. And that is the maximum amount of dots the Lewis structure will have because this element is stable. All the elements on the periodic table want to look like this guy, right? So that's what this is trying to do over here, the water. So what happens is, because it's a covalent bond, it's going to share its electrons. So hydrogen needs one more. It's going to borrow one from oxygen. And because hydrogen over here is the same, it also is going to borrow one from oxygen. Now, oxygen only has 6, but it wants to have 8, like neon. So it's going to borrow hydrogen's electron, right? So all these electrons are spinning around, sharing, going from here to here to here, back and forth, sharing, and so on and so forth, right? So that's what this is doing. So we're looking at knowing how to do the Lewis structure, understanding how the electrons, the valence electrons, are the ones that we're most concerned with, knowing that these are nonmetals, both of these are nonmetals, knowing covalent bonds, ionic bonds, and hydrogen bonds. Okay, so let's go back to our slide, or our picture here. All of this should be a review. It shouldn't be brand new to you. So because I talked about water, I want to mention its properties too. When you're in middle school, you should have done a lab, or maybe you did something similar too, but you learned about the properties of water. Water has the ability, so this is a guy in space, and this guy in space, and I hope I'm showing this picture, aren't I? Yeah, okay. So this guy in space is actually looking at a drop of water. Now that ball of water is actually billions of water molecules stuck together. The reason why they stick together is because water is a Mickey Mouse structure. It has kind of that Mickey Mouse shape. So the next water molecule can plop itself right in the middle of the one before it. So they kind of start forming like a band of water molecules. And because they do that, they have the ability to stick together. It also has to do with their chemical properties, which is more detail than we need to know. But this is called cohesion. Cohesion is the ability for them to stick together like glue. Now, if we look down here, you see this little bug, see his little feet? See how it has like an indent, like he's standing on a trampoline? That is called surface tension, what's happening. Because the bug is actually heavier than water, he can sit on the top of the water on that surface tension. If that surface tension were to break, he'd fall in the water. But because he has the ability to sit on that surface, he doesn't fall in. The reason why that again happens is because the ability of those Mickey Mouse structures of water to stick together like glue to cause this surface tension. If we look down here, here's a penny lab that you may have done, where you drop water on a penny, and as you drop the water, it makes like a little dome, and that dome continues to grow until the surface tension maximum is reached, and then it goes poof, and then your water falls over the place. And that is showing you surface tension, right? This kind of shows you how the water works. It's all kind of stuck together, like Mickey Mouse structures all stuck together. This is showing you water molecule and then their Mickey Mouse, because that's exactly what it looks like. When we come down here, we're looking at electronegativity. Electronegativity is telling you how much do each one of these elements want the electrons they need. So if we look at this table, we're going to see on the far left that francinium has like 0.7. That is the lowest electronegative element on the table. If we look at this table and we go up the table, you're going to see hydrogen is 2.2. And we're going to go to the far right. We're going to skip the last column because they're stable, neutral. They don't even care if you give them any. But here, fluorine has a 3.98. The table increases in strength as you go up and to the right. Your lowest electronegative is here. Your highest electronegative is here. So be sure that you know that information. That'll help you understand if the element is polar or nonpolar, which means is it sharing those electrons equally in a covalent bond or sharing them unequally. Here's a picture just showing you ionic bonds, showing you how he's going, hey, here, will you take this? And he's giving her a ring and she takes the ring and he's left without the ring. So it's showing how they're not sharing equally. They're actually giving and taking. This one here, covalent bond, you see how they're, oh, hey, here, you can have this. Oh, you can have this. And it was just kind of for fun. Metallic bonds, we're not actually talking about at this moment. But if you look down here, this is telling you a little bit about the types of bonding and the ionic covalent bonds and how they're stuck together. This table is just kind of give you a refresh on what you should have learned already in junior high. Okay, now let's go back to our lesson so I can show you one more thing. Why am I there? Can't see my screen at all. There it is. Okay. This is a little practice thing to kind of see, do you understand the kinds of things we were talking about today, or are you refreshing your mind? So what is the symbol for nitrogen? You look at the periodic table and tell me what the symbol is. Can anybody tell me what the symbol for nitrogen is? Anyone? Somebody's telling me, hang on.
It's just an N.
It's just an N, yeah. Kevin, great. It's an N, but remember it's a capital N, right? Okay, yeah, it's just an N. So what is the atomic number? You would have to look at the periodic table. I'll show it to you here so you can kind of see it. But you're right, it's just an N. Why is it's not letting me? Yeah, it has 7 valence, it has 7 electrons. Now we want to know how many valence electrons it has. Remember, you have to count the columns or look at the top to see what that A number is. How many does it have?
5.
5. Now, if I were drawing that structure, I'm drawing the Lewis structure, or the electron dot diagram, which only tells me valence electrons. How many dots should I draw around that?
It's a 5 again?
Yes, 5 again. Good. Okay, so if you're doing this, you can look down the page and then you'll see that the answers are here. And this has a few slides of questions to answers, questions, answers, questions, answers, and you should be able to go through that. The one thing I don't know if I told you was if you look at columns, those are called groups and families. If you look at the rows of the periodic table, which is sitting in a row, those are called periods. So you might see those questions in there. But this is a good review to kind of give you, am I following what's going on from what we talked about today? You don't have to do it. It's just for fun. I'm not assigning it as a homework assignment. It's just there to practice. So that's up to you. Remember that you have your vocabulary you need to turn in and the practice protons, neutrons, electrons that I gave you. Those are the only 2 assignments I've given this week so far, okay? Are there any questions? You guys good? Let me bring this back over here so I can see it. Everybody okay? Make sure you watch that video to help refresh your mind on bonding. But here's the point. I am not having, don't stress yourself out about all that content we talked about today. It's to build the foundation for where we're going. It's kind of just a refresher to say, okay, this would be great if you have it in your backpack right now because it's going to help you understand where we're going. It is biochemistry, so it does have to do with chemistry, and what we've covered is the basic information about chemistry. I covered several weeks of chemistry in less than an hour, so you have to remember that you're going to have to do kind of, if we come along the way and you're seeing places where you're like, I don't remember that or I don't know that, you have to ask. But today was just kind of give you the background in order for us to move forward. So I don't want you to get all caught up and be like, oh my gosh, there's no way I can do this. But I will tell you that biochemistry is the hardest topic for the entire year, even including first semester, by far. Okay, are there any questions? Okay, you are free to go, and I will see you tomorrow.
So are we finishing working on what we worked on yesterday?
Yeah, you're gonna make sure you turned in your did you finish your vocabulary?
For today?
No, it was on Monday, wasn't it? It was like 13 words.
Vocabulary.
Yeah, you had vocabulary on Monday. There were like 13 words.
No, I ain't finished that.
Okay, so you have your vocabulary to finish, and
So
then
what are
what
we
we worked
doing?
on yesterday to
We just put
finish.
the
And then that's
definition.
all I've given this week.
We just put the definitions.
Yeah.
All right.
You can either use your textbook, online textbook, or you can just look it up on the internet. It doesn't matter.
All right.
Do
Okay.
we have student support after this?
Yes.
Okay.
Do you have a class you need to go to, or did you want to meet with me?
No, I'm okay. I'll meet
Alright.
with you if I have any problems.
Perfect. Sounds good. All right, guys, have a good day.
Where's it? Every time I click the link, it sends me to like a Google Drive slides or something like that, and it won't even let me write on it.
On which one?
Um, I click practice periodic table.
Yeah, and well, you can't write on it. It's just it's like a PowerPoint.
Oh, we're just studying right now. We don't have like an assignment.
No, this is not an assignment. It's just for fun.
Oh,
So
okay.
if you look at the bottom where I gave you assignment list, it's going to show you, I don't know, can you still see my screen? Let me see if I can show you
I
what
can
I'm
see it.
talking
I can
about.
see it.
Okay. So if you go to the bottom of current lessons, let me go there real quick. If you go down the screen, right here is the assignments I've given, right? So here's the periodic table practice I gave. I'm not giving any points and I'm not making it due. So the only thing you have due for me is the biochemistry vocabulary and the atomic structure. So right now
Well,
you've only done 33 points worth of work.
I did both of those.
Then you're all set, and you can do this just for fun to make sure that you know what you're doing. The first slide just has the questions, and then the next slide has the answers, and then question, answer. And it's just practice to make sure that you were following along with what we were doing or just refreshing your mind for what you learned last year.
Okay.
Make sense?
Yeah.
Stay awake.
I am. I'm tired.
I know, me too. I didn't want to get up this morning at all. All right. Let me know
All
if you
right.
have any other questions.